So this is Chris with WCNC. I'm just going to do a quick overview on how to initially set up your computer with our CNC plasma table kit. I'm just going to do a rundown on all the basic steps to get your cuts programmed and ready for cutting. If you can, just follow along. This video is kind of a temporary setup. We are working on some better edited versions, but this one should help for the meantime. This is a basic setup call that we typically do, but it's a visual reference for some of our customers as needed. The first thing when we set up, I like to go over is Sheetcam. But first you'll see that I basically laid out all the icons on the table or on the desktop a certain way. I like to keep everything real organized and kind of set up for the orders of operation. We have the Sheetcam viewer that just kind of lets you see your CAD file just to make sure you're selecting the right ones. Inkscape is the free art software, so you can design some of your CAD files or art projects. Sheetcam is for making G-code that Mach 3 can understand and operate the table. And then finally, the Mach 3 loader is where we actually cut and it reads G-code. As you see to the right of each one, there's PDF folder files for all the instruction manuals. They are pretty thick, so we use PDF form just to save on paper and ink. So you do have these as a reference. Our WCNC table setup manual is also here. It kind of shows you how the basics of setting up the table. That will be updated here pretty soon. We're just doing a lot of editing and video recording and stuff right now. So the next one above that's for the Promo THC manual. If you add that to your machine, that goes into detail on how to operate and set those up and adjust as needed. ViaCAD is also on here. It's in our WCNC Load Up tab. There's a free trial for about 14 days. The reason we don't put it on here is once we do, that clock starts ticking. So if you do want that, it's in the WCNC Load Up folder under Programs, and then ViaCAD. And just go ahead and update that or boot that up and go through that, and you'll have about 14 days to try it out if you want. I think the license is about $30 if you want to add that as a secondary CAD file. You'll also see here we have some basic programs we put on here. There's Sheetcam, Mach 3, the Sheetcam viewer, Adobe, and Inkscape. And that's just so we have the basics for every computer that goes out. If you want to back up everything that we have, I suggest getting a USB drive. A couple gigs should do the trick. If you do, copy this folder onto that USB drive. It contains all our licenses, manuals, operator folders, programs, screensavers, and WCNC cut profiles. If you can, definitely back that up, copy everything over, everything you see on here. That way, if the computer goes bad over time or if you want to switch computers, you have everything you need. And if you need help with that, just give us a call and we'll show you how to upload or change that if you need to. Another set of folders I put on here as a reference is we have DXF files, Sheetcam job files, and then Mach 3 G-code files. I highly recommend staying very organized and labeling your files as best as possible. In the DXF files folder, you'll see here we have several test files that we've created. Typically we use those as a reference because we know those files are CAD'd correctly and something to test from. We also have our water pan slats in here. And pretty quick we'll upload the dry slats as well. So that way when you purchase our machine, you can always cut those slats as needed over time. The next one will be the Sheetcam job files. We'll go into more detail in just a minute on this, but this is where we'll save all our files that we are working on or want to modify possibly later under Sheetcam. Again, you can label under multiple folders. It's up to you, but this is a good reference to start from. We also have the same thing for Mach 3 G-code. The files that you will see here, and we'll go into more detail in just a minute, will be for your Mach 3 to read and be able to cut parts. And you can save all these here, and you can create different job names or part references, all kinds of stuff. But we do highly recommend staying very organized because as over time you'll be increasing in volume, and you want to be able to access those files long term fairly easily. So the first thing, we don't go too much into Inkscape or CAD. We recommend, there's a few videos on YouTube that we recommend. Call us for those, and we'll email them over to you. There's a lot of different CAD software out there. It's kind of find the one you're most comfortable with. Definitely I recommend trying all the free trials. So that way you can kind of pick what fits you best, because, you know, like for myself, I use AutoCAD. I use another company called VCarve, Inkscape. I use several sources to kind of create more complicated parts and jobs. But again, there's a lot of options out there, and we strongly suggest doing some research and trying out all the free trials and see which one best fits you. Most of them do have videos or training courses, and there's anywhere from ranging from $30 a license to a couple thousand. But with Plasma, 2D is the best. And usually these Inkscapes or the QCAD or ViaCAD are the best options for affordability and function. So we'll go into Sheetcam here. As you see, I just loaded it up. This is the way you'll see it when you boot up your computer. We don't set up too much in here other than our cut profiles and everything, as we want you to go through the basic setup and operation of G-code so you have a base to start from, so you can replicate it long term. The first step I tell everybody is to go to Options. You'll see that up in the top middle there. Select Job Options. And what this pulls up is the size of the material you want to reference from. You can kind of see it in the background where it's red. I recommend, it depends on your table. Most people are ordering the 4x4s or 4x8s. So we'll work with a 4x4 setup. So the X is the left to right, and we'll set that at 48 inches. And the Y would be 48 inches, and that's going to be your cut available area, a 4 foot by 4 foot type table. The next thing we want to make sure we use is the origin. You always want to select that bottom left coordinate, just because we work off of the zeros. I like to go over the thickness of material. We've had some people in the past that get kind of confused by this. It's a stock Sheetcam setting. Do not change this setting right here. It's 1.9685 if it's a reference point for Sheetcam, and not necessary to change. Some people think that you have to change the material here for metal. You do not. Just leave this one alone. The rapid clearance is adjustable. We typically will set this up at like 0.75, which is about 3/4 of an inch for beginners. What the rapid clearance does is after you pierce and the torch wants to travel, it will maintain a clearance of travel of 3/4 of an inch. We set it at 3/4 of an inch because the thing you have to look out for is parts kind of flipping up and things like that. As you get more comfortable with the machine, definitely you can go lower. But it is a setting that is adjustable, and over time, if you get more comfortable with the machine, go ahead and lower that. I typically run around 1/4 inch to 3/8 of an inch, but you do have to pay attention to the machine and kind of understand where your parts are cutting and how they're cut. But definitely play with that if you want to. Everything else, I would recommend just kind of leaving it the same. The only things I really adjust is the size on the X and Y and the rapid clearance. We also go to parking. If you want to set this now on your first setup, we use X, Y, and Z, and use coordinate 0. I will go into more detail on this in just a little bit. Nesting, you just leave a lot of these settings the same. Minimize tool change, just leave it selected here. Remnant cutoff, it's not really relevant for our type of table. Tool change, the same thing. So don't worry about those. All we're worried about is the material, which this is where you can adjust it if you have smaller pieces and whatnot. Just make sure your origin is always based off of that 0, 0 coordinate. Once you're done with that, click OK. We'll also go back to options again, except this time we're going to select machine. And we just do this as a verification process to make sure we didn't miss anything. On the machine type, you'll see that Sheetcam is available to work with a lot of different style of machines. For our plasma tables, we select the jet cutting, includes plasma, laser, and water jet. A lot of this stuff is universal beyond, around all those same tools. The next one is post-processor. You really want to make sure that it's output file units in inches. Unless you're working with metric, you can change that. We tend to select everything at always use this folder. If it's not selected, go ahead and locate on your desktop the Mach 3 G-code file. Once we create a G-code, it'll automatically go there, which will save you a lot of time and headache moving forward. The post-processor, you just want to make sure that it's our right CNC Pro Kit edited folder. At times we will change these. If we do, we can email this to you. we'll make a video for that as well. If you just scroll down, if it's not there, it's in alphabetical order. You'll see the right CNC Pro Kit towards the end, since we're at W. And then you can also notice that there's a lot of different machines that can run off for Sheetcam. But just make sure you got the right CNC Pro Kit folder. The next step is the working envelope. Again, this is more of a reference, just for drawing and scalability. I'll set these to the size of the table that we're running, 48 by 48. I'll just click enter. You'll see that the origin wasn't selected in the bottom left. Just go ahead and adjust that, and it'll go back to where it's supposed to. Click OK. Or actually, I'm sorry, go to table display and do the same thing. And then click OK. You notice as this part's kind of taking up most of the screen, your scroll tool on your mouse, if you zoom in and out, it's kind of relative to where the mouse is, but you can definitely zoom in and out here. You'll notice on these tools up here, they look like magnifying glasses. If you hover over them, you got the zoom in, zoom out, zoom to fit part, zoom to fit job, zoom window, zoom to fit material, etc. Feel free to play with these. They'll kind of get you back in place. If it ever goes black, don't panic. Definitely try looking for your part with these tools here. The first step that a lot of people can get confused, and one of the reasons we recommend Hypertherm so much is because it gives you a lot of data when you're setting up these tools. Basically, we just go here to the Create a New Jet Cutting tool, and you click that open. The first time, it'll say automatically generate name. Uncheck that. We don't like using the basic or the stock settings for Sheetcam for tool names, simply because we like to keep it more organized and give ourselves the options. As you input these tools, you can keep adding over time. Some people have over a dozen tools, if not more or less. It's just kind of depending on what kind of materials you're cutting. We're just going to go with the basic setting off of memory, so that the tool's not accurate. Just double check your manual or reference with your manufacturer of plasma cutter and to get these settings. The first way I like to label it is the amperage of which I'm trying to cut with. Typically, like I run a Hypertherm 65. We'll run lighter gauges at like 45 amps. We'll run thicker gauges at 65 amps. And so one of the reasons we start off with this is just to notify us later on which nozzle to have in our Hypertherm plasma. So we'll start off with a 45 amp tip, and that's what we're telling ourselves. We'll do underscore, and this is more just a separation so you can stay organized and reference this. Then I call out the thickness of material. We cut a lot of 16 gauge, so we'll reference off of that. If it's like 1/4 inch, just put 1/4, and that's just the thickness of the material you're cutting. And then we give another space with an underscore. Then I call out the type of material, which typically we run mild steel. But if you're running like aluminum or stainless, I would adjust that to AL or ST, but you can change that to however you like. The last one is a voltage setting. Hypertherm's really good about it. They have a lot of their voltages recommended or preset. Again, I'm just estimating here. It's going to be 129 V. Again, that'll be in your Hypertherm manual to make sure that's correct. You don't have to worry about this. It should say plasma every time, but just make sure it says plasma. The tool number, it'll just keep increasing as you add tools. So tool number 1 will be your first one. The next thing you have to do is set your kerf width, and this is specifically set based on the material and amperage you're cutting or the plasma cutter you're cutting with. Again, Hypertherm will give you that data. It's typically in your manual. I'd estimate this one at like a 0.049, and that's just calibrating the thickness of the torch flame width, and it'll actually get your parts a little bit better dimensions. Feed rate for something like this, we typically run in the 345 inch range per minute. Pierce delay, we tend to run a 0.0 pierce delay on most materials. We just found that was a better cut quality for our machines with our Hypertherm plasma. The pierce height, that's initial pierce height in some of the manuals. Those are typically 0.15 for most hypertherm models, but again, check your machine for other settings. The plunge rate for our machine, the optimal setting is 40 inches per minute. So all you do is type in 40 and hit enter, and you'll see that inches per minute automatically set up. The cut height for our hypertherm models is typically a 0.06 height. Pause at the end of the cut, I usually see in aluminums or stainless steels. So go ahead and keep that 0 for the most part. I'm just going to go back and double check the name on this one. And then click OK. And you'll see that first tool we established is over here on the left. You can adjust this toolbar. If you want to see it, if it was, depending on your screen size and everything, you can kind of adjust it to fit. You can add a bunch of tools at one time. Just make sure they're inputting the correct data based on your cutter or plasma cutter's recommendations. The next step to do a part will be to import our part. The first step I like to do is go to File, select New Part. The first time you use Sheetcam, it'll say, do you want to import drawing into this part? And we select yes. You don't have to select that every time. All you have to do is select the Don't Ask Me Again box. It's opening up on our main screen here. We want to go to Desktop, and we have some preloaded files and DXF files, so we'll select that. As you see, there's nothing here. Just double check your file type to DXF, which you'll see there's several options. The files we put on there are DXFs. So once I select that file type, you'll see our files pop in. I recommend starting with the WCNC test number 1. Just go ahead and double click that. It pulls up a window called Drawing Options, and you'll see the first time you open it, it has the scaling option. We always work in inches, but if you want to work in metric, just make sure your CAD drawings are in metric and that you want them scaled in metric. Most of the time for us would be inches. Also make sure that it's in that bottom left corner if it's your first part, but you can also select all these other ones based on the position of the material. You can bring that first part in just about anywhere on that screen and then also move it later. Click OK, and you'll see our part pop in. If you zoom out, you'll notice the scaling of this part based on our material. It's about 4 inches in square with a hole in the middle. This is just a good test file for us to practice on and make sure your machine's calibrated upon startup. Again, if you want to use these tools up here, you can zoom to fit part, zoom right in, zoom to fit material. You'll see the whole sheet, but you'll definitely want to work with that part. You could also zoom right into it. Once you bring in the DXF file, we want to give it an operation, which is basically you're telling it what material you're going to cut it on. And we do that by going to this operations column, and then select create a new jet cutting operation. It'll pop up this window. The first thing it'll ask is contour method. We typically run on an outside offset. The basic understanding of this is all our parts will cut the inside first and finish on the outside. The outside offset is referenced on the last cut. So everything else would be the opposite. So for a part like this where you have a hole in the middle and then you have lines on the outside, the inside hole will cut on the inside offset, and on the last cut it'll be the outside, and we'll want that on the outside offset to have a correct part cut. Most of the time you'll be using outside offset. The next thing you need to do is select a layer. This one is referenced as 0. Again, I recommend as you're learning, work with 1 layer drawings. In the future, we will have advanced videos and tutorials on how to do multiple layers. But for just getting started, this is good practice just to focus on 1 layer at first. Then we want to give it a tool. Because we only have 1 tool, you're going to only see that one. But as you have multiple tools for different materials, you will have the option of selecting that DXF file to various different tools. So we're just going to select the one we're going to work with today. And you'll notice the feed rate, which is also the inches per minute, automatically updated. The only other box I select here is going to be the reverse cut direction. This is a basic setting that we recommend. It pretty much, if it cuts clockwise in a circle on the first hole, on the next one it's going to cut counterclockwise. It helps with consumable life on your plasma cutter and saves you a few bucks. So I recommend using the reverse cut direction. As far as lead-ins and lead-outs, I typically will leave almost everything we do with an arc on the lead-in and lead-out. And a setting I found on the length is 0.125. It's about 1/8 of an inch. Typically, on bigger materials, I might grow that a little bit larger just so the torch has a chance to pierce through the larger material without affecting the finished product of the cut. If the hole's smaller than those lead-ins and lead-outs, it automatically adjusts those lengths. So you don't have to go in and actually change this length all the time. It'll automatically do it for smaller holes. Once you have those set and everything's calibrated correctly, go ahead and click OK. And you'll see the part turn green. I'm going to zoom into it. What Sheetcam will give you is a reference of where the torch is going to travel and where it's going to cut. The blue lines are the torch's travel. As you see, this will be your 0, 0 on your table. So it'll start here. And then you'll see the direction on the arrows. It'll typically do inside first, so the torch will travel to the start one. It'll pierce here, which you'll see that lead in. It gets away from that finish line that you might want very clean. It'll circle around, catch that first lead in, and then finish out. That just maintains a better cut quality on the product and make sure that part's dropped out. Once it's done here, it'll travel over to the furthest corner. And again, you'll see the lead in here. It'll go around. Oh, sorry, wrong way. Go around the part and lead out, which will drop this part out and it should be cut correctly based on what you need. Once we've given it an operation, let's say you want to do duplicates or several of these, you just got to make sure that you're not in the View Toolpath icon. You want to go to the nesting icon and click that. This is the only way you can duplicate or array parts for nesting. Once you're selected here, go ahead and right-click over your part. And you have a couple options. The first one's duplicate. That's typically the easiest. Once you click that, you'll notice you have control of a duplicate part. And you can go in and place that wherever you like. You can keep doing that over and over. But after 3 or 4, usually I use another option. So we're going to delete these for now. Which you just right click and hit delete on each part. Just make sure you select it first. Keeping the original. If you want to do a large array of parts or fill material, you just right click and look for array parts. There's a couple ways you can go about this. The first setting I like to adjust is part spacing. This is the gap between parts. I typically play it fairly safe when we're just starting out with a 0.25 or quarter-inch setting on the X and Y. So that way when we're nesting parts, they keep them about a quarter-inch away. You can adjust that to go tighter or larger, but that will be up to you as an operator. And we just maintain a gap between parts. That's a good starting point for learning. From here on the X2 area, sometimes I like to just fill up a sheet. And on the X is your left and right, and the Y is your depth, up and down. So like I might do 48 inches here, and all I'm saying is that it'll fit these parts as much as possible based on these part spacings in that 48-inch area. You can click enter. It's telling me that it can fit 11 parts, and it's going to be 46.75 inches on that plate. On the Y is the same thing, it just goes up and down. If I want to do 48 by 48, then click enter. I can fit 11 columns with 11 rows, and that'll be a lot of parts. For this example, we're just going to click cancel, but all it would do is just nest your whole sheet, and you can play with that and kind of work with that until you get comfortable with it. For this example, we're just going to do one part for now. And keep in mind, when you zero out your machine, which we'll get in more detail in just a minute, you always want to keep your parts referenced to this bottom left corner because this is your 0, 0. Let's say, for instance, you had your part over here you referenced your machine later at home, and the zeros here and the parts here, you could run off track or crash the machine. So just always keep in mind to keep it close to that 0, 0 coordinate. Once you have your part with the operation and everything, or arrayed, I like to tell people to save. So we just go to File, go to Save Job As, and the folder I want to look for on desktop is going to be the Sheetcam job files. You just double click that and hit Save. By doing that, it gives me access to this file that I'm working on. If I want to change cut speeds or renest it differently, I would have to save that file in the Sheetcam job folders. If you don't save that and move on to the next step, you'd pretty much have to start from scratch. The final step to be able to cut is going to be post-processing this part. And you'll see it says Run Post Processor right here with the P. You can also go into File and Run Post Processor. You'll see that because we set that earlier, that all these files, once they're post-processed, will end up in the Mach 3 G-code files. We just do that out of convenience. You can change that if you want. Again, keep labeling your parts as you feel is the best organization for you. With that additional folders or just part names. We typically will do like different job names for like a customer or things like that, or a machine type that we build. We'll have like WCNC, 4x4 or 4x8 and associated parts in there for nests and stuff like that. Go ahead and save, and it'll give you a completed signal. Post-processing was complete, so we know that we're good. If it wasn't a good file, you might see a yellow or red screen pop up. Yellow means there's probably unconnected lines, but it'll still cut. Red typically means that your CAD file might be corrupt where the lines aren't connected, or there's usually just some kind of an error in your CAD file. So typically go back to your CAD and just make sure all your lines are connected. Again, I'd recommend taking some time to practice on CAD to get familiar with that and make good CAD files. Once you have the processing complete, click OK, and that'll be it for this job. Go ahead and click Out or X, and it'll ask you, do you want to save the default tool set? Click Yes, so that way the next time you come in, you have that option to use that tool again, and that saves a lot of time in the future. Once you click out of here, we're back on our main screen or desktop. We want to go to cut the part, so we'll select Mach 3 Loader. And you'll see our profiles will pop up in here. Our most current cut profile is updated on 8/17 of this year. It typically say Right CNC Pro Kit profile. We can actually email you these if we make slight changes or make any kind of updates. As we add new machines as well too, you'll see that we can add different processes or profiles for different style machines. So we typically set it out with just this one for now, so go ahead and click OK as long as you can confirm that it's the Right CNC Pro Kit profile. So once you have Right CNC profile booted up for the Mach 3, go ahead and turn your control box on. We don't have one hooked up to this computer right now for an example. Once you do that, you'll hear your motors kind of lock in. That just means they're under power at this point. And then you go ahead and click the reset button. And this time it'll flash green on yours as long as your control box is communicating to the table and the computer. If it's still flashing, there might be an issue with like your e-stop, but definitely give us a call or message us if you're not getting good connectivity. Once that's green and registered, you can drive around the machine just to make sure that you have movement. Just confirm that left, hit the arrow keys. Left is left, right is right, up is away, down is coming towards you. Page up is the Z-axis up, and page down is Z-axis down. When you're driving around, you'll notice these coordinates start to change. Once you locate home, which we recommend putting your material on the table at this point, go to the bottom left corner of your material, usually about a 1/4 inch in on the X and a 1/4 inch in on the Y, and about a 1/4 inch off the material is optimal. Once you have that physically located on your material at your zeros, go ahead and zero your X, Y, and Z. These will go 0, on yours, and it'll actually give your machine a home. Once you give your machine a home to the material you're trying to cut, go ahead and load G-code, which you'll find here, and just look for desktop, and then look for that Mach 3 G-code files folder, and you'll see that file we created under Sheetcam. This is what the Mach 3 needs to have to read and operate the machine. You'll see that when it's loaded up, you'll see our name, the Right CNC Test number 1 file. The post processor is the Right CNC Pro Kit. You can scroll down, and you'll see like the settings we had saved for our tool settings. This is a second chance. Make sure your plasma cutter is set up properly and that you have the correct materials based on the settings you had established with this cut. Once you have the part in here, you can hit Regen Toolpath here to kind of reset everything. It'll also locate that part in this correct 00. Just because we don't have the machine hooked up right now, it won't let us register that. But yours will actually zoom in on this part. And put it on the 00. For some reason, this part didn't look accurate based on what you're trying to cut. Just go back to Sheetcam and make sure that you set it up correctly. Once you have this set up, if this is your initial setup, I also like to check the diagnostics button you'll see here on the top. And you can physically move up your floating head and down, and you'll see that switch on your Z-axis. A green light should be turning on and off here if that switch is working correctly. It's a quick troubleshoot. If for some reason the switch ever broke or anything like that, they're very affordable. We can send you one out right away. But typically we just want to make sure that the communication is proper for that floating head switch. Once you can confirm that that's communicated properly, just go ahead back to program run. And at this point, assuming you have your home 0 correct, your part on here, you can go ahead and hit cycle start, and the part will begin to cut. Before you let it cut, just make sure that you understand that the stop or alt button here, or reset, or your E-stop on your control box can stop the machine. If it looks like it's going to crash or something's not working properly, just stop it. Give us a call or message us and let us know what's going on, and we'll definitely help you with that. Typically, it's just a settings or operator error on that. We can diagnose it pretty quickly. But definitely let us know if it's not working properly there. From here, you should see that part cut. It'll travel over to the little circle inside, cut that, go to the outside and cut the perimeter, and return home. If you were able to get that far, that means your machine's running correctly. And we suggest that you kind of keep practicing and definitely try some other files and cut away. So that'll be it for this, and hopefully we get you cutting ASAP. Thank you.